All right, so is everybody where they need to be? Okay, so in this particular lesson, we're going to do two things today. We're going to graph parent functions, and then we're going to start solving some logarithmic equations. So I'm going to try and get the logarithm graphs in before lunch, and then we'll do the equations after lunch. So make sure that you do have a calculator handy. If you need one, you know where they are on the shelf. All right, so logarithmic parent function. This is the parent function. F of x equals to log base b of x. Now, you might even see it sometimes written as y equals log base b of x. Now, these two graphs, these two equations are inverses of each other. Their graphs look kind of similar. They have the same type of curve, but the placement and the direction of the curve is different. Now notice this has a logarithm in it. This one does not. This is your exponential functions, and that's what we started the week off with. This is an exponential function. This is straight up logarithm. Now, a logarithm graph typically starts close to the x-axis. It'll start close to the x-axis, and then it hits the x-intercept, and then it will make a turn. That's what a normal logarithm graph looks like. Now, when we did exponentials, we had growths and we had decays, and an exponential growth starts close to the x-axis and goes up. I have to apologize. I called this the x-axis. The logarithm starts close to the y-axis and then goes away. The exponential starts close to the x-axis and then at some point turns away. Now, the decays do just the opposite. They start high and then they end up closing in on the x-axis. Okay? So, we're going to focus on these graphs today. Most of our graphs are going to look like that on a coordinate plane. So what we're going to do, we're going to take our problem, and I'm going to write it as log, or y equals log base 2 of x. And then I'm going to write it in its exponential form. So if you remember doing that from earlier in the week, that would be start with your base, go to the other side, so 2 to the y power equals to x. Now, once I get this done, once I write it in exponential form, and some of them are a lot easier to write in exponential forms, others are not, I'm going to make my table of values. I'm going to look and see that my exponent is y. So, you know, does anybody remember my favorite three numbers that I liked using to graph my exponentials? You know where I'm going to put them this time? On the y side. Since whatever my exponent is, that's the column of my table I'm going to start. So when I rewrite these logarithmics, every single time your exponent should have a y in it in some way, shape, or form. So we're just going to do it backwards. We're not used to plugging y in and getting x out, but that's okay. We can do that. So I have 2 to the negative 1. If you recall, that's 1/2. 2 to the 0 power, which is always 1. And then, of course, 2 to the first power, which is 2. Now, our domain is typically x is greater than 0. Our range is normally all real numbers, which is the exact opposite of exponentials. We'll talk about the end behaviors once we see the graphs and what it's doing. Our x-intercept comes out of the table. It's that 0 point. So our x-intercept is 1, 0. And our asymptote is going to match the domain. Now, is domain x or y? Is the domain x or y? X. So x equals to 0. When x is equal to 0, that's the y-axis. So just like here, I told you we start close to the y-axis and then we'll curve away. So as we plot these points, you'll see that the graph kind of starts pretty close to your y-axis, which I'm kind of highlighting in red. So when I plot that point, I go over, I'm going to enlarge that graph a little bit so y'all can see a little bit better. I'm going to go over 1/2 and down to 1. I'm going to go to 1, 0, which is my oh, I know it's off. I was just enlarging it so you could see the graph. I'll shrink it back down in just a second. And then I'm going to go over 2, 1. So you can see the first point is close to the y-axis, and then the other 2 points are kind of going away. So when you draw in your curve, you start close to the y-axis, and then you follow the curve away from the y-axis. You never turn towards the y-axis. You never cross your asymptote. Everybody okay with that? All right. So in this problem, problem number 2, first thing I'm going to do is I'm going to take f of x out and write it as y. I'm going to rewrite it in exponential form. So 1/3, which is my base, to the y power equals to x. So 1/3 to the y power is going to equal to x. Once I rewrite it in exponential form, I'm going to make my table. Since I only have a y as my exponent, I'm going to use my favorite 3 numbers. 1/3 to the -1 power. If you type that in your calculator, you will get 3. 1/3 to the 0 power. If you type that in your calculator, you will get 1. And 1/3 to the first power stays 1/3. Our domain does not change. We're going to stay all numbers bigger than 0, all x values bigger than 0. My range does not change. Remind me to go back to problem number 1 because I forgot to talk about the end behaviors. Our x-intercept, I can come to my table, pull that. That's 1, 0. And then remember, your domain and your asymptote are going to match. So your asymptote will be x equals 0, which is the y-axis. We have not moved off the y-axis yet. So I'm going to enlarge the page just a minute so we can get so you can see my graph a little bit better because that's awful small grid. So when we were at x equals 3, what was our y value? When we were at, x equals 3, what was our y value? -1. What's my next point? 1, 0. 1/3 and 1. Now, although a lot of times we start at the bottom and curve away, see how I do have a point pretty close to the y-axis and then the other points are curving away? That's fine. The reason this graph starts this way and curves is because the base number was a fraction. Okay? If your base number is not a fraction, you'll start at the bottom and you'll curve away, but when it's a fraction, it just kind of reflects it. All right, so let's talk about the end behaviors. Now, we have two values. We have 0 and we have infinity. We have the domain value and we have the infinity value. Okay? Now this says as y approaches positive infinity. This is positive infinity. Is that approaching 0 or is it approaching something else? Are you getting closer to that line? So we're approaching 0. Here is negative infinity. So as y approaches negative infinity, my arrow is going towards positive infinity. You only have two choices, your domain value or your asymptote value and infinity. Okay? So having said that, if this is positive infinity as y approaches positive infinity, this arrow is going this way, so it's going away from 0, so it's approaching infinity. As y approaches negative infinity, notice that this arrow that's pointing down is closing in on your asymptote. So that one would close in on 0. So you have to decide if it's 0 or infinity. Any questions about the first two? Still a talkative group, I see. All right. Now, my domain is about to change. And if your domain changes, that means your asymptote is going to change. Notice that number 3 has a group, has a parentheses, but number 4 does not. Do you agree that I have a number up here, but it's within the group, and this one is not? There's two totally different scenarios going on. When you have the group, that changes your domain. So we're going to set x minus 1 greater than 0. So that means my domain is going to be greater than 1. I only do that if I have a parentheses. If I don't have a parentheses, we stay at 0. Which means my asymptote is now at x equals 1. So everything I do in this graph is going to be the right of that dashed line, because we are shifting this graph to the right one spot. Now my range, still all real numbers. We'll finish our end behaviors in just a minute, and we'll get our x-intercepts once we get our equation written. Okay? So the first thing I'm going to do, the rewrite's going to be a little bit different because I do have that group. First thing I did, I took f of x out, replaced it with y. I'm going to rewrite 4 to the y equals that parentheses x minus 1. Last thing I'm going to do is add 1 to both sides. So I get 4 to the y plus 1 equals to x. That is what I'm going to build my table around. Now, keep this in mind, because every time you have a group, this is what your final equation should look like when you have the parentheses. When we do this one down here that does not have that group, the outcome for the rewrite's going to look a little bit different, okay? So keep that in mind. All right, so now I'm going to build my table. My exponent is just y, so I can use my favorite 3 numbers. We're going to have a little extra work to do this time because we have that plus 1. Okay, so I'm going to go up to the top. That would be 4 to the negative 1 with a plus 1. 4 to the negative 1 is 1/4, and 1/4 plus 1 is 1 1/4. Do y'all agree with that? Next one, I'm going to plug 0 in for my exponent. So 4 to the 0 plus 1. 4 to the 0 is 1, and 1 plus 1 is 2. And then I'm going to plug 1 in for y. So 4 to the first power plus 1. That would be 4 plus 1, which is 5. So when you plot these points, you're going to start really close to that asymptote that we drew in, the dotted line, and then at some point you're going to curve away. So when I go over to 1 1/4, I go down to 1. I'm going to enlarge that so y'all can see a little bit better. So I go over 1 1/4 and down to negative 1. I go over 1, 2, and 0. By the way, that's your x-intercept. And then I'm going to count over 1, 2, 3, 4, 5, and up 1. So you can definitely see the move away from that asymptote. Now, your end behaviors, one end approaches infinity, the other one approaches 1, approaches that asymptote. Not 0, but 1. So as y approaches infinity, this is positive infinity. This arrow is going away from the line, so that means x is approaching infinity. As f of x approaches negative infinity, or as y approaches negative infinity, this ending, because you're going down towards negative infinity, is closing in on that asymptote. So that would be a 1. You only have 2 options. It's the asymptote or it's an infinity. Any questions about that one? All right. Now, the rewrite for number 4 is a little bit different because we do not have the parentheses that keeps x minus 2 together, okay? So the first thing I'm going to do, I do not have a group. Do y'all agree? There's no parentheses. So my domain is going to stay greater than 0, which means my asymptote will stay at the y-axis. My range, still negative infinity to positive infinity, and we'll get our x-intercept out of our table. So the first thing I'm going to do over here as far as rewriting is concerned, I'm going to take f of x out and rewrite that logarithm. Now, since I do not have a group that keeps x and negative 2 together, I'm going to move that number. If it were plus 3, we would subtract 3. If there's no parentheses grouping it together, you're always going to do that first. So that's y plus 2 equals log base 3 of x. Now you are ready to rewrite this. Grab your base, set it equal to your power, which just so happens to be y plus 2, or raise it to that power and set it equal to x. So my equation looks a little bit different. Now, put a star by this one because we are going to change our table. My favorite 3 numbers are not going to work this time. So what I'm going to do, I'm going to build my table around that exponent. Y plus 2 equals 0, so I'm going to build my table around negative 2. Y and negative 2. So I'm going to put negative 2 in the middle, negative 3, negative 1. I'm going to throw 0 in because I'm going to need that point to identify my x-intercept. So I'm going to go ahead and do that 0 point. Everybody okay with that so far? I'm going to clean off some room up here so we can do a little bit of math. All right, so the first number I'm going to plug in is negative 3. So 3 to the negative 3 plus 2 power gives me 3 to the negative 1 power, which is 1/3. I get 3 to the negative 2 plus 2 power, which gives me 3 to the 0 power, and anything to the 0 power is 1. And then I'm going to take 3 to the negative 1 plus 2 power. That gets me 3 to the first, which is 3. And since I have to identify my x-intercept, I've got to do that one extra point. So that's going to be 3 to the 0 plus 2 power, which is 3 squared, and that would give you 9. So you do not have to graph 9, 0 unless you just want to, but that is your x-intercept. That's where the graph will actually cross the x-axis. Let me know when you're caught up because I'm going to enlarge that graph again so it's a little bit easier to see. All right, so since we said our asymptote was going to stay at the y-axis, when I plot all these points, I'm going to have one that's really close and then the other ones are going to move away. So when I go over 1/3, I go down to negative 3. I have 1, negative 2, 3, negative 1, and then you can even go all the way out 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So you can definitely see it curving away from the asymptote. So it's going to start going up here. It's going to curve and not cross the x-axis till it hits that point. All right, so here's infinity, here's negative infinity. Which x value approaches infinity and which one approaches 0, the asymptote? As x approaches, or as y approaches positive infinity, what is this arrow doing? Close to the asymptote or going away? Don't all of you yell at me at once, you will scare me. Going away. Awesome. As y approaches negative infinity, so as that arrow goes down, it's approaching the asymptote, which is there. Everybody good? All right, so we did not make it all the way through. I did hear the lunch cart, and I do not want to rush through these last two. So we will start here after we finish lunch. So on 5 or 6, we have to do both. We have a group and then we have that exterior number. So remember, if I can get my pen to write, probably should have done that before I started. So remember, we're going to take the group, and that's what's going to change our domain. So x plus 9 greater than 0. So x is going to be greater than negative 9, which means my asymptote will be over here at negative 9. So we now have an asymptote over here at -9. Everything we graph is going to be on the right side of that line. Our range, still all real numbers. We'll have to graph it so that we can get these two things. So when you go to rewrite your equation, first thing, of course, replace f of x with y. Now, what you're going to move is anything that's outside the group. So I'm going to subtract 4. So I get y minus 4 equals log 1/2 of that group. It's okay to have the group, but anything on the outside of the group has to be moved. You don't have a choice. So now I'm going to rewrite 1/2 to this power. So y minus 4 will be my exponent, and that's going to equal x plus 9. And then the last thing I'm going to do is I'm going to subtract 9 from both sides. My final equation is 1/2 y to the y minus 4 power minus 9 equals to x. Now, since my exponent changed, my table will change, and I will build my table around that value. So y minus 4 equals to 0. So the first number I'm going to put in that table, I'm going to build my table around my exponent. So that would be 3, 4, 5. Everybody okay with what I've done so far? All right. So let me get some of this out of the way so we can plug those numbers in and get our table. Now remember, the equation is 1/2 y minus 4 minus 9 equals to x. So the first thing I'm going to do is I'm going to plug in my negative or my 3. So that would be 1/2 3 minus 4 minus 9. That gives me 1/2 to the -1 power, which ends up being 2, and 2 minus 9 is -7. I'm going to plug in 4. So that would be 1/2 to the 4 minus 4 power minus 9. 4 minus 4 is 0, so 1/2 to the 0 power minus 9. Anything to the 0 power is a 1, so 1 minus 9 is -8. And then the last number I'm going to plug in, that would be 1/2 to the 5 minus 4 power minus 9. That's 1/2 to the first power minus 9. So 1/2 minus 9 is -8.5. Any questions about how I got the numbers in the table? All right, so I'm going to plot my points. I'm going to go over, I'm going to enlarge it first so we can see it a little bit better. I'm going to go over 1, 2, 3, 4, 5, 6, -7 up to 3. I'm going to go over to -8 and up to 4. And then I go over -8.5 and up to 5. So see how one point is really close to that asymptote that we drew in and the others are curving away. Now remember, the reason this graph looks like this is because our base number was a fraction. Okay, now I have to do one more point because I need my x-intercept, so I've got to plug 0 in. So that's 1/2 0 minus 4 minus 9. So I have 1/2 minus 4 minus 9. So I need you to, on your calculator, type in 0.5, which is 1/2, to the negative 4 power, get that answer, and subtract 9 from it. Anybody get an answer? You got 7? So that means when I go over 1, 2, 3, 4, 5, 6, 7, I'm at 0. So my x-intercept. So this graph is going to come all the way over here, and it won't cross the x-axis till it hits that point. Now, remember, this is positive infinity. This is negative infinity. Which one, the positive or the negative infinity, is closing in on the asymptote? The positive or the negative? Which one closes in here? The positive one. So that would be 9. And that means that this one moves away from the asymptote. So that would be the infinity answer. Okay. To me, the hardest part is getting the equation rewritten in its proper format. Okay, that's the hardest part to me. So number 6 is going to rewrite just like number 5. First thing I'm going to do is I'm going to calculate my domain. I took my group, set it greater than equal to or greater than 0, so x is greater than 2. What else do I use that number for? The asymptote. So x is 2. Your range has not changed for any of these problems. And then these we're going to have to get from the graph in the table. First thing we're going to do, take f of x out, replace it with y. You will always move the outside number. If you've got a number that's not in that group, move it first. So that will be y minus 1 equals to that logarithm with that group attached. Now you're ready to take your base number. So 5 is going to be raised to the y minus 1 power, and that's going to equal to the group x minus 2. And then the final step would be to add 2 to both sides to get x by itself. Now, I have to change my table because my exponent is just not a y. So y minus 1, take your exponent, set it equal to 0. I'm going to build my table around 1. So 1 goes in the middle, 0 and 2. So 0, 1, 2. Good thing for us, this top number is going to give us our x-intercept, so we don't have to do an additional point. So I'm going to start plugging in, use my calculator if necessary. So 5 to the 0 minus 1 plus 2 gives me 5 to the negative 1 power. Now remember, anything to the negative 1 power has to flip. So that would be 1/5 plus 2. So that's 2 1/5. I'm going to plug in 1 next. So 5 to the 1 minus 1 power plus 2. That gives me 5 to the 0 power plus 2, which is 1 plus 2. And that outcome is 3. Then my last number in my chart, 5 to the 2 minus 1 plus 2. And that gives me 5 to the first power plus 2, which would give me 7. So I changed my table because my exponent changed. If your exponent is just y and it doesn't have a plus 2 or a plus 3 or a plus 4 or anything like that, you can use my favorite numbers. But these last couple of examples, we weren't able to do that. All right, so my asymptote is at x equals 2. So everything we do is going to be to the right of that line. So I'm going to go over 2 1/5, and I'm going to stay put. By the way, that's our x-intercept. I'm going to go over 3 and up 1. Then I'm going to go all the way out to 4, 5, 6, 7, and up 2. So you can see how we are really close. And then, of course, we turn away. All right, so which one gets the infinity as far as the end behavior is concerned, and which one gets the 2? Because you always use the infinity or 2. Does this one get infinity or 2? So that means this one gets the 2. All right, everybody okay with graphing logarithms? All right, so let me scroll down. The next page you should have in your packet should look like that. Okay, so what we're going to do with this, and these are my favorite logarithm equations. Do you remember the properties that we did the other day? Where you had the product property, you had a log plus a log, and you pulled it together with multiplication. We're going to have to apply some of those properties here. So what we want to do is we want to get a logarithm equal to a logarithm, because if you can get one logarithm equal to another logarithm, then you can take these numbers and set them equal. So m equals to n. Okay, now notice that the bases have to be the same. So it has to be a log base 2 equals a log base 2. It can be just a log equals to a log, a base 10 log. So in the first couple of examples, the first 3 to be specific, we have a log base 5 equal to a log base 5. There's nothing else. So what we will do is we will take the groups, we will set them equal to 0, and we will solve it. I subtracted 5x from both sides. Now, I don't know if you read number 3. It says solve and check for extraneous solutions. The reason you have to solve and check for extraneous solutions is this number and this number. They always have to be positive. So I don't care what your outcome is, what your answer is. If you plug it back in here and get a negative number, you have to throw your answer out. Okay? So 5 times 9, that's 45, plus 9, which gives me a positive. That's good. 6 times 9 is 54, and that's also positive. So I checked it here, I checked it here. I can keep that answer. Okay? If either one of these groups, when I plugged in my answer, turned into a negative, you have to throw that answer out. Okay? So I have a log base 2 equal a log base 2. So I can take my numbers and set them equal and solve it. So 1 minus 4n equals to 2n plus 43. I'm going to add the 4n, so that gives me 6. I like positive numbers. So 1 equals to 6n plus 43. I don't have a choice but to subtract 43. So that gives me negative 42 equals to 6. N, so what does n equal to? Negative 7. Okay, now I do have to check both of those numbers. So 1 minus 4 times negative 7, that gives me 1 plus 28, which will give me a positive number. And if I take 2 times negative 7 and add that to 43, which was the second group, although I get negative 14 plus 43, the outcome of that will still be a positive number. So I can keep that as an answer. Just because my answer is negative doesn't mean I throw it out. What cannot be negative, I checked that group, it was okay. I checked that group, it's okay. All right. Now, I'm going to let you do number 3 without me, because it is a log base 9 times a log base 9. Make sure you check your answer. All right, so I said 6 minus 3w equal to negative 2w. When you add 3w to each side, you get 6 equals w. When you plug it in, 6 minus 3 times 6 gives me 6 minus 18, which is negative. I don't even have to check the other one. If any of those groups, any of those numbers are negative, you're done. But even if you check this, negative 2 times 6 gives me a negative also. So it doesn't work in either one of them. So just because you come up with an answer does not mean that you can keep it. That's what they call extraneous solutions. You come up with an answer, but it's not a valid answer. Okay. Now, the next 3 examples use our properties. Okay. So on the first one, I have a log plus a log equal to a log. So I'm going to have to use one of my properties to rewrite this as a single logarithm before I can set my numbers equal. So would I multiply or divide those 2 groups? I would multiply. So y plus 5 times 4, and that's going to equal to log of 72. So I took both of those, used my product property that we talked about the other day, and I condensed it down to 1. Now I can set this value equal to this value. So I have 4 times y plus 5. All I did is I moved the 4 to the front. To me, it's easier to distribute from the front than the back. If it doesn't bother you, distribute from the back. So that is 4y plus 20. When you subtract your 20, you get 52. And when you divide by 4, you should get 13. Double check my math. Now, you always have to check your answer. Lucky for us, this is the only place I have to plug 13 in. There's no y here, there's no y here. So 13 plus 5 stays positive. Do y'all agree? So we keep that answer. All right. Number 5. The only property that I see we need to use is the power property. Move that power back. So I get log base 7 of 4 to the 3rd power equals to another log base 7 of that group. Now I've got a log equal to a log, so I can set this value equal to that one. 4 to the 3rd is not 12, it's 64. So I went ahead and changed 4 to the 3rd to 64 equals to 4a minus 8. Add my 8, I get 72. And when I divide by 4, double check my math, I believe you get 18. Okay. Now, I only have one place that I have to check, because there's only one number with an A. So 4 times 18 is 72, and 72 minus 8 stays positive. So I can keep that as my number. Number 6. How do I pull these two values back together to write 1 log base 4? Do I multiply them or do I divide them? Divide. Now, can you divide 68 by 4 evenly? Can you reduce that? And it reduces to? So 68 divided by 4 is 17. I get 3n plus 11, and that's what I have to solve. So I'm going to subtract 11, and that will give me 6 equals to 3n, and when you divide, n is equal to 2. In the first logarithm, there's no variable. Second logarithm is okay. This is the one that I have to check. 3 times 2 is 6, and 6 plus 11 stays positive, so I keep that answer. All right, the last 2 examples that we're going to do today, and then we're going to stop because the next page has a different type of equation on it. I have my power property here, so I'm going to have to raise 25 to the 1/2 power. Do you remember what a fractional exponent actually represents? Okay, so 25 to the 1/2 power is actually the same as the square root of 25, which is 5. So I'm going to go ahead and simplify that to log base 6 of 5. There is nothing I need to do with the other side. Do y'all agree? No powers, no. So now all I have to do is set it equal, solve it, and check it to make sure I can keep that answer. So 5 equals to 23 minus 4W. When you subtract 23, you get what, 18? Yeah. Negative 18. Thank you. And when you divide by negative 4, you get 18 over 4, because negative divided by negative is positive, and that would reduce to 9 over 2. Now, the only place you have to check that answer is here. Does 23 minus 4 times 9 over 2 stay positive or not? Okay, so we can keep 9 over 2 as our answer. All right, I apologize. We do have 2 more down here because we do need to do these. I thought that page started our second example. I have 2 properties that I have to use on the left side. The right side. What 2 properties do you see? I only have 1 logarithm on the left already, but I have 2 logarithms. I have to do my power first. That is correct. So that would be 6 squared. So I took care of my power. There are 2 properties. What's the other one? Division. So I'm going to write 1 log base 3 with a fraction behind it. 6 squared, which is 36 over 4. 6 squared, which is 36 over 4. So I am ready to take this value, set it equal to this one. So 2p minus 5 equals to 9. Where did 9 come from? By dividing. I add 5. I get 14. I divide by 2. I get p equals to 7. Two times 7 is 14. 14 minus 5 stays positive, so I'm good. All right. Do you see any properties that need to be dealt with in number 9? Do we have a multiplier that we need to put back as a power? Do you have a log plus a log or a log minus a log? So I'm ready to take these 2 values and set them equal. So m squared, equals to 18 minus 7m. We have an m squared. That's a quadratic. So we're going to have to set this equal to 0 and try to factor it. Hopefully it will factor. If not, your fallback is quadratic formula. So m squared plus 7m minus 18 equals to 0. You would add 7m and you would subtract the 18. Now, lucky for us, this factors. And I am going to kind of give you a heads up. When they first introduced this particular concept to you, when you set them equal and you get a quadratic, most of these are set up to where they will factor for you. Okay? So factors of negative 18 that give me 7 are positive 9 and negative 2. 9 times negative 2 gives me negative 18, but when I add those 2 numbers together, I get the positive 7 in the middle. So my two answers come from taking each factor, setting them equal to 0, solving them. So I took my first factor, my second factor, set them equal to 0, and solved them. Now I have to decide, can I keep both answers? Do I keep one and throw the other one away, or do I have to throw them both out? Those are your options. Keep them both, keep one, keep none. So negative 9 squared is positive 81, so it's good there. 18 minus 7 times negative 9, that gives me 18 plus 63, so we're good with negative 9. Do y'all agree? All right. 2 squared, we're good because that's a positive. And then 18 minus 7 times 2, that would be 18 minus 14, which is still positive. So we're good with the 2. Any questions about number 9? Like I said, if you end up with a quadratic, when they first introduce these to you, they should all factor. It's very, very rare that you come up with one that does not factor. All right. Last example. What property do I multiply or divide when I pull these two back together? Multiply. So 2 times k squared. I already have one logarithm on the right, so I don't have to do a property on the right. And I apologize for not putting my groups. So now that I have a logarithm equal to a logarithm, I take the 2k squared and I set it equal to the k squared plus 16. When I subtract k squared, I get k squared equals to 16. Do you recall the square root property? What would I do to get rid of the square? Take the square root. Now, remember, there's always a plus minus aspect that I warn y'all about all the time. People forget that. So that would be k equals to plus minus 4. The square root of 16 is exactly 4. So I have two answers that I have to check. I have to check positive 4 and negative 4. When you square 4, you get 16, so we're good here. When you square 4, you get 16. 16 plus 16. Okay. When you square negative 4, you get 16. And when you square negative 4, you get 16 plus 16, which is still positive. So we're positive all the way around. Do y'all agree? So we can keep both of those answers. Now, sometimes you do all that work and you have to throw both answers away once you check it, and that's okay. You can have up to 2 answers and all the way down to 0 answers for these. All right, so that's where we're going to stop for today. All right, I hadn't put it in there yet.